Hey guys, welcome to the first LearnAP live stream. We'll be answering your questions on AP Calc right now. So if you have any questions, go ahead and ask away in the comments. In the meantime, I'm just going to be working out some problems here on this note just for practice. All right. Okay. So let's start here with a pretty simple question. Convert r equals 3 sine theta to Cartesian. Now again guys, what we want to do here is we're going to try to convert it to these two equations. Or these three, I'm sorry. Y equals r sine theta, x equals r cosine theta, and r squared equals x squared plus y squared. So what we can do is multiply both sides by r. And we're left with this. And if we wanted to simplify it, I could simply say so that's how we would do it. Okay. So that was a pretty easy one. Let's go to something maybe a little harder. So convert y equals ln of x plus x squared plus y squared to polar. So again, we're just going to use these master equations for polar. There is one with tangent, but these are the main ones that you will be using basically all the time and that you really should know. So r squared equals x squared plus y squared, y equals r sine theta, and x equals r cosine theta. And so you might notice that this is similar to the unit circle, where x is cosine and y is sine. So here, all we're going to do is just plug these in. I have y right here, so I'll plug in r sine theta. Here I have x, so I'll plug in r cosine theta. And here, x squared plus y squared, r squared. So again, this is something that's only on the BC exam. So if you're an AB, you don't need to know this. Alright, so let's move on to something a little bit different. Let's talk about inverse functions. So let's say f of x equals x squared minus 3x and g of x equals x plus 1 let's find the inverse of f of x over g of x. So find the inverse. Well, the first thing we're going to want to do is we're going to want to actually write out f of x over g of x. I'm going to call this h of x. Alright, I'm just seeing this comment from Arnold. I want to thank you for referring us. I'm glad you guys find us helpful. As usual, if you guys have any ideas to improve the videos, things you'd like to see, we're merely here to help you guys out, so don't hesitate to let us know. Alright, so moving on, we're just going to write out f of x over g of x. So here we go, x plus 1, and here's h of x. Now, again, when we're finding the inverse, we want to say y equals, so y equals x squared minus 3x over x plus 1. And now swap x and y. Now, here we want to ask ourselves, is this function one-to-one? And this is a good question. And again, we don't have a graph in front of us, so probably the best way is to just solve it and see. So switching x and y. And then we're going to solve for y. And here this might be a little difficult. And since we have multiple y's here of different powers, I can say pretty much that this might not be a function. Now here what I would do is do synthetic division, and then I would solve that and I would see whether this is a function. But we're not here to talk about it, so we're just going to skip that and just go on to sort of calculus-based questions. Alright, so again, if you have any questions, do ask away. For the time being, I'll move on to another example question for the inverse. So find the inverse whether it exists or not of absolute value y equals absolute value of x. So if you remember that first video that we talked about for functions, you might remember that this can also be written as the square root of x squared. So that's how I'm just going to write it right now. Swap x and y, and we're left with x equals the square root of y squared, which is also just x equals square root, I'm sorry, not square root, absolute value of y. And so here we can see that if I wanted to solve this, I would say x equals y and x equals negative y. But again, this is not going to be a function. This graph here would sort of look like this. And then there are domains here, so when y is greater than 0 and when y is less than 0. I'm sorry, this should be negative x. Apologize. So those are our functions. And again, this would be a function, but we can see in the domain that this is just depending on where y goes. So we have this y equals x here when y is greater than 0, and y equals negative x when y is less than 0, as opposed to the actual absolute value, y equals absolute value of x, where this is based on what x is doing. So we'll move on. For this one, I'm going to use coordinate axes, which I need here. Come on. Sorry. Okay. So let's put those here. Okay, and I will put 2 of them. So last video, in the first video of our channel, we talked about functions, and I talked about the absolute value function. This is also something you might have to do for the AP test. So let's say this is function this is function f of x right here, and it looks like so. Call this -3. Alright, we'll call this 5. We'll call this 3. And they might say, okay, draw absolute value of f of x. So here, we have to think about what absolute value means. So what it means is anything that's going into this is coming out positive. So the numbers are going to stay the same. They're just going to be positive. So here, all I have to do is draw this function here, but keep all the lines above the x-axis. So things that are negative, so say this part and this part, I'm going to reflect them over the x-axis. So I'll draw our points here at -3, 3, and 5. So everything greater than 0 is going to look the same about, just trying to sketch this the same. And then everything that is negative is just going to be reflected. So this part here, I'm just going to reflect it and make it positive. Again, here this is negative, so I'm reflecting that and making it positive. And so here would be f of x, and here is absolute value of f of x. Similarly, if I erase this, oops, I'll keep that on. Alright, so if I erase this and I write negative absolute value of f of x, again we have to think about what this means. So anything that comes out of here is positive, and here we have a negative. So positive times a negative is a negative. So everything that comes out of this is going to be negative. So that means that what we did last time, where we drew absolute value of f of x, we drew everything positive. Well, now we're going to draw everything negative. So again, here this is staying the same. But again, we want the absolute value of the function, and then we want to make that negative. So here when it's less than 0, we take the absolute value of it, that's making it positive, and then negative, so it's going back to negative. But here when we're greater than 0, we're taking the absolute value, it's staying positive, but then we're multiplying it times a negative, so that's going to make it negative. So our graph, again, these positive parts, we're just reflecting over the x-axis. So here, this is all positive here, so we're flipping it negative. This is negative, so it's going to stay negative. And then again, here we have a positive. We're going to flip it. Okay. So let's talk about rational functions now. If this will let me scroll down. Okay. So let's talk about rational functions. Last time I talked about end behavior. So what I mean by a rational function, and I'll write this out, is we have polynomial over a polynomial. So for example, we could have, say, 3x squared over 5x to the 5th, or we could have, or I'm sorry, this would not be a rational function, but plus x to the 4th. This would be a rational function. I'm sorry, I take that back. So this would be a rational function. So these are going to come up a lot on the AP test. So we're going to talk about end behavior here. So again, if we have, say, 3x squared plus x over 5x to the 5th plus x to the 4th, we want to think about, well, what is this doing as it goes to infinity? So here, since this exponent is greater than this, and this is on the bottom, this is going to 0. I do see that we have a question, however, so let me jump to that real quick. So we have the limit as x goes to 9 of square root of x minus 3 over x minus 9. Okay, good question. So I'll write this out. So limit as x goes to 9 of square root of x minus 3 over x minus 9. So if you guys remember, what we should do first when we're trying to solve a limit is direct substitution. So here, you've probably plugged this in. You can see that we're getting 0 over 0, and this is indeterminate. So if I had like a number over 0, this would not exist. Or I'm sorry, this would go to infinity. Or it might not exist. If I had like 0 over some number, then that's just 0. 0 over 0, you have to do more work. So I haven't talked about this yet, and this will be coming up in the video next week. I'm sorry, a week from next week. We're going to talk about how to solve limits. And so one method is to do what's called conjugating the denominator. And all that means is, so let's say we have, we'll write out our limit. All we're doing is we're going to conjugate the denominator. So we're going to multiply the top and bottom by this term right here, but I'm going to make it positive. So square root of x plus 3. Whoops. Okay. So here we can see that if I multiply these two, I'll get x minus 9. And on the bottom here, I'm left with x minus 9 over, or I'm sorry, times square root of x plus 3. I can cancel these terms, and I'm left with the limit as x goes to 9 of 1 over square root of x plus 3. And now we can do direct substitution. 1 over square root of 9 plus 3, and that's 1 over 6. So good question. Alright, so if we go back to rational functions, I'll talk about this a little more. Why this is going to 0 at infinity, so I'll just make this a little more clear. So if we want to think about this, this is sort of thinking about infinity in abstract terms. When I plug in infinity to x squared, this is infinity. But when I plug in infinity to x to the fifth, I'm also getting infinity. So how is it that this over this equals 0? Well, you have to think about the speed at which we're going to infinity. X squared goes to infinity pretty quickly, but x to the fifth is going to go to infinity much faster and reach a greater number. So a way to think about this is I have what is a smaller infinity and a bigger infinity. And so this over this is 0. Now similarly, if I erase this, let's say that this is 3x to the fifth over 5x to the fifth. Here I have the same infinity at the same speed, and then I'm multiplying this. Now these are just going to cancel because they're going at the same rate, they're the same infinity, and so that's why this would be 3/5. So this is what I mean when I talk about end behavior in my previous videos. And similarly, if say this here was 2, I have infinity squared over infinity to the fifth. Here I have a much bigger infinity, here I have a smaller, and so this goes to infinity. You almost want to think about this smaller infinity like being like a whole number, because you would know that infinity over 5 is just infinity. So that's one way to think about it. Okay, so we have another question. We want to find the the derivative of x squared, but by the limit definition. So I'm going to talk about this coming up in our videos, but I've talked about the difference quotient. Which you guys know, limit as h goes to 0 of f of x plus h minus f of x all over h. Now, what I didn't tell you is that you use the difference quotient to find a derivative. So if f of x equals x squared, then the derivative is just this. And that's what we call the limit definition of a derivative. So, you should know how to set this up. So just f of x plus h. So anytime we see x in f of x, we're going to plug in x plus h. Here we only have 1, so it's simple enough. Minus f of x, which here is just x squared. And again, I always say it, first thing we do when we're trying to solve a limit is plug in 0. So here, if I plug this in, I'm going to get x plus 0 squared minus x squared over 0, which comes out to 0 over 0. So indeterminate. So we have to do a little more work. Let me just scroll down for a second. Okay. So it's indeterminate. We have to do more work on the problem. So the first thing you should always do is if you have something squared or a polynomial like this, you should multiply it out. Now that's not always true. If I had x squared plus 5x to the 5th to the 14th power, don't multiply that out. That's going to take you forever. There's probably a much easier way. Here it's simple enough, so we're just going to multiply it out. X squared plus 2hx plus h squared minus x squared all over h. Now here, all I have to do is simplify. So I have x squared minus x squared, so now I just have 2hx plus h squared all over h. So here, limit as h goes to 0, I can cancel out these h's, and I'm left with 2x plus h, or 2x. So that's the limit definition of the derivative of x squared. And this is how we would denote this derivative. Or, I guess just to make it more clear, I'll write f prime of x. That's another way. So if you guys knew the power rule, you knew that answer already. However, it's just good to know the limit definition. You might be asked to do it on the AP test. Now, I believe I also wanted to explain it a little more. Okay, so again, let me scroll down. Scroll down a little bit. Okay. So let's say we have a function f of x. We'll say x squared. Now before I get to this, I also want to mention you guys might have seen this written like the h as delta x. Both are correct. I've avoided using delta x early on just because early on people tend to think that it's x when really it's a totally different thing. Each one's completely correct. Delta x is just a little bit more accurate. I'll explain it in a second. So here we have our f of x equals x squared. And if we think about what a derivative is, really it's the slope at some point. So if we have some point here, our derivative is going to be the tangent line. So the derivative at a point is the tangent line. Okay. Now, how do we actually find that tangent line? What we can do is draw an approximation of it. So if I want the tangent here, maybe I'll draw a secant line. Oh, before that, I'll say tangent line hits the function at one point. So I don't know how to do that, but I do know how to approximate. So here I'll draw what's called a secant line, where it's hitting this function in two places. Now this is an estimation of our slope. Here at this point I'll call C. And now the difference between these 2 points we'll call delta x. Now, as you might know, as I squeeze delta x smaller and smaller, we're going to get a closer secant line and a better estimation of the tangent line. So the equation for the tangent line, or I'm sorry, the secant line, which is our approximation is we have rise over run. So here we're going to call this f of x. And here we're going to call this f of x plus delta x. So if I want the slope here, I'll take my rise, and then we're subtracting it, all over my run, which here is just delta x. And here's our equation for the secant line, for the slope of the secant line. Now, as I mentioned earlier, as delta x gets smaller and smaller and smaller, or as I wrote up here, h, we're going to get a better and better approximation. Now, the best approximation is no approximation at all, actually having the secant line. So if we squeeze delta x infinitely close to 0 but didn't get it there, we would have it. So I'll write the limit as delta x goes to 0, which is what that is. We're squeezing delta x really, really small before closer and closer to 0, but it's not actually going to get there. So, and then I'll just write this out. And this looks a lot like this. And that's because it's the same. That's where the difference quotient comes from. Now, I will have a video going over this later. If you guys weren't aware, we upload new videos for calc every Tuesday and Thursday. So if you want to see that video, be sure to subscribe. Alright, so I hope that answered your question. I guess we'll move on to some more, unless you have another one. Alright, well, before I go over anything else, I also want to talk about just limits in general. So, as I mentioned earlier, what I mean by the limit as delta x approaches 0 is delta x is getting really, really close to this number here, but it's not actually going to touch it. So it's infinitely close, but not 0. If delta x were 0, we would have, so I won't write that. So I'll say delta x equals 0. So if delta x actually equaled 0, I'd have this, which is just 0 over 0, which might sort of confuse you guys, but here we're not taking a limit. 0 over 0 is just does not exist. But if we get infinitely close but don't touch it, we can do operations like this, which is the derivative. Okay, so let's move on. I also want to talk about period and amplitude a little bit. Not really the easiest thing to sort of figure out, so I'll talk about it a little more. Okay, draw my coordinate axes. Okay. So if I draw y equals cosine x, so here's 1, here's negative 1, this is pi over 2, and here's pi. What I mean by amplitude is basically the peaks of the function, which are here. What is the distance of that? Now that might be sort of confusing, so you could also think about it as if I took this over here the two peaks and sort of drew dashed lines and then measured this distance, which I'll call d, our amplitude is the absolute value of d over 2. So if you guys have any more questions on that, ask away. But I do see we have another comment, so I will get to that. Okay, so here we're talking about parametrics. Again, if you're in AB, you don't need to know this. If you're in BC, you should know the stuff about parametrics. So we want, I'm assuming you want me to write a parametric equation for y equals x to the 5th plus 3x squared minus 10x plus 23. And then you're welcome. I'm glad you're enjoying it. So we want to write, assuming you want me to write this as a parametric. If that's not the case, be sure to let me know. Alright, so one thing to know is when we're writing parametrics for Cartesian equations, there's not one way to do this. I could, if I really wanted to, say x of, well, I'm sort of jumping ahead. So in Cartesian we have f of x equals something. Well, in parametric we have x of t. Okay, and then this is some function of x, so we have some x in here. Parametric we have x of t equals something involving t, and y of t equals something involving t. So that being said, there's no one way to write this stuff. If I really wanted to, I could say x of t equals x to the 5th plus ln of the sine of x. But I find when you're doing this, there's no need to make it so hard on yourself or so complicated. So honestly, what I always do is I just say x of t equals t, or x equals t. And now if you see in this equation that y is just x, or I'm sorry, that x is just t, we can say y of t equals this equation, except writing it with t's. So t to the 5th plus 3t squared minus 10t plus 23. And so here are our parametric equations. Now note that here we had a function, so I have y equals. So that made it really easy. I could just say x of t equals t, and then rewrite the original with just t's. Sometimes, and in fact I'll write one out now, we'll say y squared plus y to the 5th equals 3x squared minus x to the 6th plus sine of x. Now we get into something a little more complicated. We're say, and this is just an example, this might not have a pretty solution that will work, but this is just to show you guys. Here if I wrote x of t equals t, and now if I say that y of t, and I just rewrite this, I'm going to get 3t squared minus t to the 6th plus sine of t, which looks simple enough, but this is in fact wrong. Because if you think about it, this is also saying y equals. Here we don't have y equals, we have y squared plus y to the 5th equals. So that's the problem here. And so you would have to write this some other way. almost all the problems they give you like this will have a simple and clear way to do it. So, but this I just made up off the top of my head, so it might take really long to solve. So, not going to go over it, but if this is confusing you, do leave a comment, but you shouldn't really worry about stuff like this. This is sort of extraneous on the AP test, and this is not going to be the main focus. Alright, so I hope that answered your question. If you guys have any other questions, be sure to ask away. Alright, so I can also talk about this challenge problem solution where I said, what is the parametric equation y of t equals sine t, x of t equals cosine t. And the answer was the unit circle, your favorite. And here there's a solution up on our website, but I just wanted to sort of walk you through it. If I look over here to my review the unit circle notes, I can see that I wrote somewhere, okay, right here, that coordinates are written as cosine theta comma sine theta. Well, that's exactly what we have right here. X equals cosine t, y equals sine of t. So it's not saying theta, but it's just a different variable and it means the same thing. Another way to think about this is the unit circle. The word unit in math equals 1. So if I found what's called the magnitude of this function, or how big is this, I would square both sides and add them together and take the square root. So our magnitude is going to be square root of y of t squared plus x of t squared. If you haven't learned about magnitude yet, don't worry about this, but if you have, this is sort of a good way to think about it. So if I plug our values in here, I get sine of t squared plus cosine of t squared. And if you recognize this, this is our trig identity. This equals 1. So I have the square root of 1, or 1. And that's why it's called the unit circle. And we can see that in our parametrics that this is just equaling 1 the whole time. Again, if that confused you, I wouldn't really worry about it. But if you're confused, we can see here that, in fact, around the entire unit circle, that we just have distances of 1. It's certainly most evident here at the axes, but knowing that it's a circle, you can deduce that, okay, r equals 1, so therefore this is 1. Just know that in the future, you know, we're sort of small right now, but definitely as these get sort of more people on them, will certainly be more helpful and sort of answer more questions. So definitely, if you guys found this video helpful, be sure to share it with your friends. We would like to help as many people as possible and answer your questions rather than me just sort of going over random topics. That being said, we can still talk about some other things. Okay, good question. Will the unit circle parametric stuff be on the AP test? Not directly. However, you understanding that this right here is the unit circle is certainly very important to you understanding not only the unit circle, but how parametrics work. So I would definitely try to understand this explanation here if you're confused. There's a solution to this on our website. You can go to learn-ap.com and go under problem solutions and then go to video 2, and there will be a PDF of all this worked out. But good question. This won't directly be on the AP test, but you should definitely understand it. That is, unless you're in AB calculus, in which case parametrics aren't on the AB test. But for BC, you should definitely understand this. So good question. Alright, we can talk about something that will be on the AP test for sure, and that's limits. We can go back to limits. So let me sort of get set up and draw the coordinate axes, if it will let me. That's not what I want to do. Okay, here we go. Okay, so we'll get our coordinate axes, move that over, boom, okay. So let's say we have a graph of f of x, and we have some function that looks like so. In fact, rather than me just writing this out, I'll actually define it for you guys. So we'll say f of x is a piecewise function, so when x is greater than 0, it's x squared, and when x is less than or equal to 0, we have x cubed minus 5. So what this is going to look like, whoops. Alright, so this is the graph of f of x, and this is going to look like so. I'm sorry, that was a poor drawing. Okay. So here's f of x. So if we have, so let's talk about limits here. And I'm specifically concerned with the limits as x goes to 0. Now think about, now I talked about this in our limits video, or I will. As x gets really close to 0, what is this value approaching? Well, as we get close to 0 from the right here, we're coming to 0. But from the left, we're coming to 5. I'm sorry, negative 5. So what is the limit then? Well, here it would not exist. And this is called a jump discontinuity. Because here the function is sort of jumping up at x equals 0. And so we don't approach the same limit from both sides. Now, it's important to note that, this is a mistake that a lot of people make, is they'll say, oh, okay, I'm sorry, of f of x. Say, I have a limit as x comes to 0 from the left. I have a limit as x goes to 0 from the right. Maybe they're not checking what is. They say, oh, well, this limit, this exists. And that would be wrong. These numbers have to be the same. So a lot of times on the AP test, they'll tell you prove that a limit does not exist. So this would be a really good way to do it. So if we write this out, I'll say does not exist, or I'll erase this. I'll do this sort of step by step. So we're going to prove that the limit as x goes to 0 of f of x does not exist. So we can say that if limit as x goes to c of f of x exists, then limit as x goes to c from the right equals limit as x goes to c from the left of f of x. Yeah, important that you put in f of x. It's not wrong per se, but I wouldn't do it because you're not actually denoting what this limit is. That would be like writing y equals 3, not writing the plus sign, and then 5. So that's sort of what it is. Always put something after the limit. And then we can say limit. So back to our limits. So here we have 0 from the right. 0 is our c in this case. And limit as x goes to 0 from the left. Here we're going to get 0, -5. And so we can see that the limit as x goes to 0 from the right is not equal to the limit as x goes to 0 from the left. Again, I missed my f of x. Don't do that. Therefore, limit as x goes to 0 of f of x does not exist. You might want to write 0 is not equal to 5, -5. That might seem obvious, but, and I don't think it's necessary, but you know, why take your chances? It takes 2 seconds to write. So this is how we would prove that a limit doesn't exist if I were taking the AP test. Alright, so we're nearing the end of our live stream. I think we have time for maybe one more question if anybody has any. I'll sort of chill out for like 15 seconds or so, but if not, I'll just go over something until the end of the hour, where we'll be starting our Chem live stream. So if you're in AP Chem as well, do stick around for this. Okay, it doesn't look like we have any more questions so far, so I'll just go over something that I think I went over it in my video, but it might not have been very clear to people, and this is a mistake that a lot of people make on the AP test, so I will go over it very quick. So I talked about holes. I'll just wait for a second. Okay. I talked about holes. So if we have f of x equals x minus 2 over x minus 2 times x squared, we have a hole at x equals 2 because our denominator equals 0 at that point. And I talked about if you cross cancel these and write f of x equals x squared, and then you're asked to find f of 2 and you write 4, that this is wrong. So I'm going to explain that a little more. Now remember before I jump in, I'm going to get my coordinate axes. Okay, so here if I draw this, I just have f of x equals x squared, because at every point where I have x minus 2, it's just canceling each other. I'm sorry, these x minus 2's are just canceling each other out no matter what x is. Now again, there's an important exception. At x equals 2, we have a whole. X can't equal 0. And so this is f of x equals x minus 2 over x minus 2 times x squared. Now if I draw quickly here on the right, we're sort of running out of time, but that's okay. F of x equals x squared. I can see that there's no whole here. So in this, to avoid confusion, I'll write g of x. So here in g of x, g of 2 is just 2, because here, 2, 2. However, here, I can see that at 2 I have a whole, so f of 2 does not exist. So you might be wondering, well, I want to cancel these out. I don't want to keep writing x minus 2 over x minus 2. How should I write f of x? Well, we can just write it as f of x equals x squared. X cannot equal 2. So that's a good way to think about it. It doesn't look like we have any more questions, so I'm going to go ahead and stop the calc live stream, and I'll be picking back up in just a minute for the chem live stream. I want to thank you guys for tuning in. I hope you found my video helpful. If you did, be sure to sort of get the word out. We're trying to do that ourselves, but the more it's people asking and me helping people, sort of better than me just sort of sitting around and doing random practice problems. That being said, I hope you guys enjoyed this video, and I will see you next week at the same time for the calc live stream. We'll be picking up in a couple minutes with the chem live stream.